Hello friends, and welcome to the first part of our little crash course about fractions. The first things that we're going to look at are the four basic operations of fractions, meaning addition, subtraction, multiplication, and division. Addition and subtraction are a little bit funky because we do need the same denominator. It gets a little hard for some students, so let's start with those two. All right, the first fraction that we have, or I guess the first problem that we have with fractions is on the left-hand side, and it is 2/5 plus 1/5. When we add and subtract fractions, we keep the denominator the same, so I'm going to leave a 5 on the bottom. Next, we do the operation that is presented to us, in this case addition, between the top two numbers, 2 and 1. That's 3. Okay, not too bad. Can we reduce this fraction? No, unfortunately not. So this is our final answer. Let's move on to the next one. Here we have sevenths that are being added. So the first thing that we're going to do here is a fraction with a 7 on the bottom. Great. Now we perform the addition presented to us, the 3 and the 5, which gives us an 8. Some of your teachers may require you to rewrite this as a mixed number. Let's practice doing that. 7 goes into 8 once. 7 times 1 is 7, and we need one more to get to 8. Okay, well, how did that line end up there? Let's get it away. Okay. On the left-hand side, you should see a problem that has a whole number in it. Let's see what we do about that. Since we want to have fifths, so over 5, we want to make sure that whatever number we put over 5, when we divide it, it becomes 4. Well, 5 times 4 is 20, and if you whip out your calculator or just reach into your mind, however good your multiplication table skills are, 20 divided by 5 is 4. So we really haven't changed the problem much. We just rewrote 4 as a fraction with a denominator of 5. Let's subtract. 20 minus 6 is 14 over 5. As a mixed number, 2 and 4/5. 5 goes into 14 twice. That's 10. Then we need 4 more to get to 14. Okay. The last problem I have here for you are two mixed numbers that we're adding together. Although they do have the same denominator, I suggest the most foolproof method of doing this is to turn these mixed numbers into fractions first, and then do whatever addition subtraction that we need to do, turn them into mixed numbers later if necessary. Okay. A little review on how we turn mixed numbers into fractions. We multiply, and then we add. So our first mixed number, 5 times 1 is 5, plus 3 is 8. 5 times 3 is 15, plus 4 is 19. Perfect. Let's add. We get 27/5. 5 goes into 27 5 times. That's 25. And we need 2 more to get to 27. Okay, not too bad. But what if we don't have the same denominators? Let's check it out. I'm going to zoom in. Give me a moment. All right. If we look at 4/3 minus 5/6, you should notice something special about those denominators. 3 and 6 are pretty closely related. We can take 3 and turn it into 6, which would be great because then we'd have a common denominator. Well, let's do it. To turn 3 into 6, I need to multiply it by 2. But if I multiply the bottom by 2, I must multiply the top. Gotta keep things balanced. So what's our new subtraction problem? 8/6 minus 5/6. 3/6 is our answer, which I can reduce to 1/2. Let's take a look at this next one. All right, now I can't do the same thing as we did before. I can't turn 8 into 10 or 10 into 8. However, I do know that both of them can multiply into 40. That can be our common denominator. Let's give that a shot. In order to turn 8 into 40, I must multiply it by 5. In order to turn 10 into 40, I must multiply it by 4. Now, if you couldn't think of 40 right away, the next two problems will do in a foolproof method, and I'll mention that a little more. But let's do this problem this way. So what are our two new fractions? Well, first of all, they both have denominators of 40. Perfect. And then we have 15 over 40 and 28 over 40. When we add those together, we get 43 over 40. And let's just practice. 40 goes into 43 once, 3 left over. All right, so these two I'm going to do with what I call the foolproof method. And this foolproof method is, if we have two fractions with two different denominators, and you just cannot think of what that common denominator could possibly be, you can multiply the first fraction by the denominator of the second fraction, and the second fraction by the denominator of the first. Our new fractions are 3/15. Oh, so 15 is our common denominator. Now we know. And 10/15. Let's add 13 over 15. Can I reduce that? Unfortunately not. That's that. Okay, again, two mixed numbers. I'm going to turn them into fractions before I find their common denominators. 7 times 7 is 49. 49 plus 5 is 54. 6 times 3 is 18, plus 1 is 19. Okay, again, we do not have a common denominator. Let us create one. We multiply, the first fraction by the denominator, I don't know what's going on, I'm sorry guys, by the denominator of the second, and the second by the denominator of the first. Let's see what we get. Well, we get a common denominator of 21, which is wonderful. 3 times 54 is 162, and 7 times 19 is 136. No, it's not 136. There's no way it's 136. It is 130. Oh my gosh. Why is my brain blinking? I know it's 130. It's 133. Yikes. Sorry, y'all. We all have brain farts from time to time. I was doing some multiplication in my head instead of on a calculator. Okay, so we have a common denominator of 21. Perfect. And let's do subtraction. 162 minus 133 is 29. See, that was fine. Let's turn this one into a mixed number, just in case your teacher does require it. 21 goes into 29 once, with 8 left over. Okay. So addition and subtraction, I think, is as hard as fractions get in their basic operations. So let's move on to multiplying and dividing. I'm going to zoom in. Okay. Now when we multiply and divide, there's two options of doing this. We could multiply or divide straight across and then reduce. I think it's better to reduce first. And yeah, let's see how this goes. So speaking of reducing, let's see if we can reduce the 6 with anything. The only things that I can reduce 6 with are the 7 and 13 on the bottom. Can I reduce 6 with 7 or 13? Unfortunately not. How about the 5? Can I reduce it with 7 or 13? Again, no. Since I can't reduce, I'm going to multiply straight across. 6 times 5 is 30. 7 times 13 is 91. Can we reduce this? No, we cannot. So that's our final answer. All right, let's move on to this right-hand problem. I'm going to start with 12. Can I reduce 12 with 15 or 14? I can actually reduce it with both. What do I feel like doing? Well, let's just reduce it with the 15. Why not? Why not? Okay. So, I can divide both 12 and 15 by 3. That gives us a 4 here and a 5 there. Great. Well, let's see. Can I reduce anything else? Can I reduce this 9 with the 5 or the 14? No. However, I do have a new number. I have a 4. Can I reduce the 4 with anything? Well, yes. I can reduce it with the 14. So this 4 gets reduced twice. Okay. I can divide both of these by 2. 4 divided by 2 is 2. 14 divided by 2 is 7. Ha, fantastic. Anything else I can reduce? Well, can I reduce this 2 with anything anymore, with the 5 or the 7? Nope. Can I reduce the 9 with the 5 or the 7? No. Okay, we have fully reduced, which means we can multiply straight across the top and straight across the bottom. 2 times 9 is 18. 5 times 7 is 35. I already know I can't reduce this because I reduced everything possible in the fraction. I still check because I'm not perfect and maybe I missed something. All right. Multiplying mixed numbers requires us to turn them into fractions. So let's do that. Okay. 8 times 1 is 8 plus 7 is 15. 2 times 6 is 12 plus 5 is 17. Okay, let's see what we can reduce. 15. Can I reduce it with an 8 or 6? Well, I can reduce it with a 6. I can divide both 6 and 15 by 3, leaving us with a 5 and a 2. Okay, can I reduce the 17 with the 8 or the 2? Unfortunately not. We have a new number up here. We have a 5. Can I reduce the 5 with the 8 or the 2? Nope. Okay, we're ready to multiply straight across. 5 times 17 is 85 over 16. Okay. Shall we practice doing mixed numbers? Why not? Okay. 16 goes into 85 5 times. 16 times 5 is 80, which means we're left with 5/16. Whoops. Okay. Sweet deal. Let's do this last one. You see that 5? It's a whole number, but every whole number can be written as a fraction. So I'm writing it as 5 over 1. Okay, let's see if we can reduce anything. Can I reduce this 5 with the 1 or 15? Oh, why yes, I can reduce it with the 15. I can divide both of them by 5. The 5 becomes a 1, 15 becomes a 3. Can I reduce this 7 with anything? No, not the 1 and the 3. It doesn't really change much. I do have this new 1. Can I reduce that with 1 and 3? Technically, yes. Will it change anything? No. So, let's multiply straight across. 7 times 1 is 7. 1 times 3 is 3. And let's practice our mixed numbers. 3 goes into 7 twice, with a remainder of 1/3. All right. Let's do our last operation, which is dividing, and then we'll be done with this part. As you can see on the right-hand side, zooming in again, by the way, we're going to do some equation examples in the second part of this video. Or I guess on the second video about this subject. Okay, dividing. Dividing fractions is the same as multiplying, with one extra step. Let's do it. This extra step is rewriting the first fraction, writing a multiplication symbol instead of a division, instead of a division, I give up. No, I don't. I don't give up. There we go. Alright, let's start that over. I rewrite the first fraction, I write multiplication instead of division, and then I turn the second fraction upside down. Now we're back to multiplying. So let's see what we can reduce. Can I reduce the 7 with the 5 or the 2? Nope. Can I reduce the 35 with the 5 or the 2? Why, yes, indeed. I can reduce it with the 5. I divide 5 by 5, I get 1. 35 divided by 5 is 7. I know that 7 is new, but we've already seen whether or not we can reduce 7 with anything on the bottom. The answer was no, so we've completely reduced. Let's multiply straight across. 49 over 2. And of course, we can simplify it or rewrite it as a mixed number because we can't simplify it. 24 and 1/2. Okay. This next problem, the one on the right-hand side, has a whole number. And recall that just recently, in the multiplication part, I rewrote 5 as 5 over 1. I can do that with any whole number, and so can you. So I rewrote 4 as 4 over 1. Let's begin the division process. Rewrite first fraction, write multiplication, flip second fraction. Let's reduce. Can I reduce 4 with 1 or 5? No. What about 6? Nope. Okie dokie. It's time to multiply then. 24 over 5, which we can rewrite as a mixed number, 4 and 4/5. Okay, 2 more and we're good to go. Once again, we have a whole number here in this left-hand side, so I'm going to write it as 5 over 1. Now, I will begin. 12 over 13 times 1 over 5. Whoopsie daisies. I wonder where that came from, whoopsie daisies. I should look that up. If any of you know where whoopsie daisies, that phrase came from, comment below. Can we reduce 12 with 13 or 5? No, unfortunately not. Can we reduce 1 with 13 or 5? Technically, yes. Will it really do much? No. So let's multiply straight across. And we get 12 over 65. I know I can't reduce it because I didn't reduce anything in the problem, but I look at it, think about it a little bit, and I'm positive I cannot reduce it. All right, let's do this last problem. Just like in multiplication, when we have mixed numbers, we need to rewrite them as fractions. 8 times 1 is 8, plus 7 is 15. 2 times 6 is 12, plus 5 is 17. Okay, so we have our division problem, which we rewrite as a multiplication problem. Perfect. Let's see what we can reduce. Can we reduce this 15 with 8 or 17? Unfortunately not. How about this 6? Why, yes we can. We can reduce it with that 8. We can divide 6 by 2 and get 3. And we can reduce 8 by dividing that by 2 and getting 4. Okay, let's just double check these numbers and make sure the new numbers don't reduce with anything. The new numbers are 4 and 17 on the bottom, 15, 3. Can I reduce 15 with 4 or 17? No. Can I reduce 3 with 4, 17? No. Okay, we're good to go. Let's multiply straight across. 15 times 3 is 45. I saw that 6 on the left-hand side and almost wrote 65. Oh my! All right, then we multiply the bottom. 4 times 17, 68. Okay, I know that I can't reduce it because I reduced as far as possible during the problem, but let me look at it a little bit. All right, we're good to go. So, this is the end of the first part of our little crash course of fractions. Part 2 will be about solving equations, and I'll give you several methods of doing those as well.